What if everything you've ever believed about the universe has been backwards? We're told from childhood that the cosmos came first, that in the beginning there was matter, energy, and expanding space, and only billions of years later, consciousness flickered to life in the fragile networks of brains. But what if that story, elegant as it sounds, is only half of the truth, or perhaps the wrong half entirely? What if consciousness did not emerge from the universe, but instead the universe emerged from consciousness? This is the impossible question, the riddle that refuses to stay buried. It strikes at the very root of science, philosophy, and spirituality alike. Physics is built on the assumption that reality is external, objective, and indifferent to our thoughts. Neuroscience builds upon it, treating the mind as a late-stage byproduct of neurons firing. And yet, when you look closer, when you listen to the cracks in the foundation, the ground beneath this assumption trembles. What if perception is not a side effect of particles, but the stage upon which particles exist at all? What if we are not mere spectators in a cosmic theater, but the unseen authors of the play? The audacity of such a question can feel destabilizing, even dangerous. After all, the narrative that matter precedes mind has given us extraordinary predictive power. It is this assumption that allowed us to send rockets into space, to split atoms, to build computers. The materialist model has teeth, it works, and it works spectacularly. But effectiveness does not always equal truth. A map can guide you without revealing the actual terrain. What if the model of matter first, mind later, is just a useful sketch, not the final truth of things? To feel the weight of this paradox, imagine two mirrors facing each other, reflecting endlessly. Which came first, the image or the mirror? In the same way, we are trapped between two possibilities. On one side, consciousness is born from matter like a flame struck from flint. On the other, matter is born from consciousness, like shapes emerging from a dream. Each view flips the script of reality, and both cannot be true, or can they? Science, as we know it, insists on one version. According to the standard cosmological tale, the universe began with a Big Bang 13.8 billion years ago. Out of an unimaginably dense point burst spacetime, expanding into stars, galaxies, and eventually planets. On at least one of those planets, complex molecules formed, giving rise to biology, then brains, then thoughts. In this telling, consciousness is fragile, local, temporary, an accident riding on top of physics. To claim otherwise, to say consciousness itself is foundational, is often dismissed as mystical hand-waving, philosophy dressed up as science fiction. Yet history warns us not to be too certain. Time and again, the certainties of one age collapse into the absurdities of the next. Once the Earth was believed immovable at the center of creation, until Copernicus and Galileo revealed we orbit the sun. Once space was thought absolute and fixed, until Einstein showed it bends and warps with mass and energy. Certainty has a way of being temporary. Could our current assumption, that matter gives rise to mind, be the next in line to fall? Consider the role of the observer. Physics tries to treat the universe as existing independently of us, but quantum mechanics unsettles that comfort. In the double-slit experiment, particles behave like waves, spreading out and interfering, until we observe them. The act of observation seems to collapse probabilities into definite outcomes. Consciousness, somehow, intrudes. Are we glimpsing a clue that reality itself does not crystallize until it is experienced? Even if we resist the temptation to make consciousness central, we cannot escape the unease it stirs. The hard problem of consciousness remains unsolved. How do atoms, molecules, and neurons, however complex, give rise to the vividness of inner experience, the redness of red, the pang of sorrow, the wonder of starlight? Physics can describe the spin of electrons and the curvature of spacetime, but it is mute about why anything feels like anything. If matter alone explains everything, why is there something it is like to be alive? This is where speculation begins to creep in, daring to suggest that maybe our starting assumptions are wrong. Maybe consciousness is not an afterthought but the source. Maybe awareness is woven into the fabric of the cosmos, just as gravity and electromagnetism are. Some traditions whisper that mind is the ground of being, that matter is simply a projection, a play of appearances arising within awareness itself. Could it be that physics, for all its brilliance, is only describing the ripples on the surface of a deeper ocean? The paradox becomes sharper when we examine perception itself. Everything you know about the universe comes through consciousness. Every scientific measurement, every mathematical equation, every sensory input is mediated by awareness. Without consciousness, there is no observation, no measurement, no science. So is it truly rigorous to say that matter creates consciousness, when our only access to matter comes through consciousness itself? It is like trying to prove the existence of a lamp using only the light it casts. Which is more fundamental, the lamp or the light? To live inside this paradox is to stand at the edge of two worlds. One is hard, material, external, ruled by laws and indifferent to us. The other is fluid, subjective, inward, shaped by the mysterious act of awareness. Each world claims to be primary, each world has evidence, and yet neither can fully banish the other. This is the impossible question. Does mind come from matter, or does matter come from mind? Or more provocatively, could both be illusions, shadows cast by a reality we cannot yet name? The beauty of the question is not in its answer, but in its disruption. It forces us to confront the arrogance of certainty. It forces us to ask whether we are asleep inside a narrative we mistake for truth. And it forces us to reconsider our role in the cosmos. If consciousness is primary, then we are not passive accidents of evolution. We are participants in the very unfolding of reality. The stars above us, the ground beneath us, may not exist independently at all, but only within the stage of awareness. Imagine for a moment that your thoughts are not private ripples in a tiny skull, but threads in the loom of the cosmos itself. Imagine that the laws of physics are not indifferent machinery, but patterns emerging from the collective dreaming of consciousness. Imagine that the universe looks back when you look at it, that the galaxies themselves shimmer because someone, something, is aware. To embrace this possibility is to feel both terrifyingly powerful and humblingly small. For if we create reality, then reality creates us in turn. The circle closes. The mirrors reflect endlessly. This then is where our story begins, not with answers but with a fracture in certainty. The universe, consciousness, matter, mind. Which is the origin and which is the echo? To ask this question is to step into the unknown. To resist it is to remain asleep inside assumptions. And so we must press forward, guided by both wonder and doubt, willing to let the question itself reshape how we see everything. But to do that, we must first look at the ground science has already laid for us. Before we can overturn the old assumptions, we must understand them in their full power. The universe as machine model is not to be discarded lightly. It is to be studied, respected, and challenged. Only then can we test whether consciousness might truly shape the cosmos, or whether it is only a dream yearning for more meaning. If consciousness is not the foundation of everything, then what is? For modern science, the answer has long been clear: matter. The universe in this telling is not born of awareness but of blind physical processes, unfolding according to impersonal laws. Consciousness, if it exists at all, is a latecomer, an evolutionary quirk of complex brains, with no special status in the cosmic order. This is the orthodox view, the bedrock of physics, the machinery of matter running without mind. To understand why the alternative, that consciousness comes first, sounds so radical, we must first step into the triumphs of this matter-first worldview. The materialist story begins at the very edge of time, the Big Bang. Roughly 13.8 billion years ago, from an initial singularity smaller than an atom, space itself expanded. Energy condensed into particles, quarks, electrons, photons. Forces differentiated, gravity pulling masses together, electromagnetism binding charges, strong and weak nuclear forces sculpting the atomic nucleus. Out of this primordial chaos, order slowly emerged. The first hydrogen and helium formed, then stars, then galaxies. Gravity collapsed gas into blazing furnaces where heavier elements were forged in nuclear fire. Over billions of years, These elements seeded planets, oceans, and eventually the chemistry of life. In this model, mind is an epiphenomenon of matter's long dance, an afterglow, not a cause. The elegance of this worldview lies in its predictive power. The laws of physics describe, with uncanny precision, phenomena ranging from the spiral of galaxies to the flicker of electrons. The same equations explain the orbit of the moon and the fusion in the sun's core. The standard model of particle physics, though incomplete, maps the zoo of subatomic particles and the forces that govern them. Quantum electrodynamics predicts experimental outcomes with 12 decimal places of accuracy. Einstein's relativity predicts gravitational waves that ripple across spacetime, detected a century later by LIGO. This is the triumph of matter-first thinking. When we treat the universe as a machine, we can measure, manipulate, and predict it. But the machine is cold. In this framework, there is no intrinsic purpose, no teleology. The universe does not care, it does not notice, it simply is. Humans, with our fleeting sparks of awareness, are passengers in a blind, mechanical cosmos. Richard Feynman once quipped, "The universe doesn't care about our petty little problems." In the matter-first story, this indifference is not insult but fact. Consciousness is not woven into the structure of reality. It is an emergent property like the foam on a wave. If matter is primary, then the mind is secondary, fragile, local, temporary. The stars will burn out, the galaxies will thin, entropy will win. Consciousness will vanish, and the machinery of matter will grind on without us. And yet the more we admire the machine, the stranger it becomes. At the smallest scales, matter itself is elusive. Quantum physics tells us particles are not solid billiard balls but probability clouds, flickering into being only when measured. At the largest scales, cosmology hints at mysteries we barely grasp. Dark matter and dark energy dominate the cosmos, yet remain unseen and unexplained. The elegant machine reveals gaps, anomalies, mysteries that materialism cannot yet solve. Still, the materialist insists, we need not invoke consciousness to fill these gaps. Give us time, and the machinery will explain itself. From this vantage point, consciousness is demystified. Neuroscience argues that mind emerges from brains, which emerge from biology, which emerges from chemistry, which emerges from physics. Strip away the poetry, and consciousness is simply neurons firing, neurotransmitters flowing, electrical signals dancing in tissue. Francis Crick, co-discoverer of DNA, called it the astonishing hypothesis. Your joys and sorrows, your memories and ambitions, are nothing more than the behavior of nerve cells and molecules. The machinery explains the mind, not the other way around. In this hierarchy, physics is the foundation, and consciousness the last ripple in the chain. The matter-first story is not without its romance. It speaks of a universe vast beyond comprehension, where the laws of physics are universal and timeless. The same equations that describe a candle flame describe a supernova. The same principles that govern a drop of water govern the spiral arms of galaxies. To live in such a universe is to be humbled by its scale, awed by its indifference, and inspired by its knowability. Carl Sagan captured this wonder. We are a way for the cosmos to know itself. But note the phrasing, we are a way, not the way. In the matter-first story, consciousness is a brief window, not the foundation of existence. Still, this view carries philosophical costs. If matter alone is real, then meaning itself is an illusion. Our sense of purpose is just chemistry. Love is oxytocin, awe is dopamine, grief is serotonin imbalance. Every subjective experience is reducible to mechanistic cause. This is the bleak face of materialism. Consciousness as an accident of carbon, extinguished when the neurons cease firing. For some, this is liberating. It strips away superstition and centers truth in the measurable. For others, it feels like a cage, reducing the infinite richness of awareness to the grinding of biological gears. And so we arrive at the tension. On one hand, the matter-first model works. It predicts eclipses, powers satellites, and guides medicine. On the other, it leaves something vital unspoken. What about the redness of red, the pang of longing, the sheer fact of being. Physics can chart galaxies but cannot explain why it feels like something to look at the stars. Neuroscience can trace neural pathways but cannot explain why the firing of neurons produces the taste of chocolate or the grief of loss. The machinery explains everything but the most immediate fact, consciousness itself. To dismiss this gap as trivial is to ignore the hardest problem of all. If matter explains consciousness fully, then the vividness of experience is redundant, a strange and unnecessary side effect. But if matter cannot explain it, then the matter-first worldview is incomplete. Either way, the question lingers like a ghost at the feast. What is consciousness, and why does it exist at all? In this section, we have walked through the triumphs of the materialist worldview. We have seen its precision, its grandeur, its cold indifference. We have acknowledged its explanatory power and its philosophical cost. The universe as machine is a story that has given us rockets, medicine, and microchips. But the story leaves an absence at its core. It explains how the cosmos works, but not why it is experienced at all. This absence is where the impossible question creeps back in. If consciousness is not merely an emergent ripple, if awareness is more than an evolutionary accident, then perhaps the machinery of matter is not the whole story. Perhaps it is only the surface. The paradox grows sharper when we realize that physics itself, in its deepest formulations, hints at something consciousness cannot easily be excluded from. But before we get there, before we dare to put consciousness back into the foundations of reality, we must examine where physics itself breaks down. At the smallest scales of matter, at the level of quantum mechanics, the machinery falters. And it is there, in the strange and haunted world of particles and probabilities, that the role of the observer returns with unsettling force. Physics prides itself on objectivity. The goal is to describe reality in terms of laws that remain true regardless of who is watching. A rock falls whether a child or a scientist observes it. A planet orbits a star whether or not anyone looks up at the night sky. For centuries, this assumption of independence has worked brilliantly. But in the early 20th century, when physicists probed the quantum world, the ground shifted. Suddenly, the act of observing seemed to matter. At the smallest scales of reality, the observer could no longer be ignored. The story begins with light. In the 1800s, Thomas Young's double-slit experiment demonstrated that light behaves like a wave. Shine light through two narrow slits, and it produces an interference pattern, dark and bright fringes on a screen. Yet decades later, when scientists repeated the experiment with individual particles of light, photons, the result was shocking. Even when fired one at a time, the photons created the same wave-like interference pattern. Somehow, each photon seemed to pass through both slits at once, interfering with itself, as if it were a ghost splitting into possibilities. But the real mystery emerged when detectors were placed at the slits to measure which path the photon took. Once observed, the interference pattern vanished. The photons behaved like solid particles, choosing one slit or the other. It was as though the mere act of observation forced reality to decide. Unmeasured, the photon lived in superposition, a blur of possibilities. Measured, it collapsed into a definite state. Observation didn't just reveal reality, it seemed to shape it. This is the infamous observer effect, and it lies at the heart of quantum mechanics. Electrons, atoms, even molecules behave this way. They exist in a haze of probabilities, described by the wave function, until an observation collapses them into a single outcome. Erwin Schrödinger dramatized this paradox with his thought experiment, a cat sealed in a box with a quantum trigger that could release poison. Until observed, the cat is both alive and dead, a superposition of states. Only when the box is opened, when observation occurs, does the cat become definitively alive or dead. The story is absurd, but the equations are not. At the quantum level, observation and outcome are inseparable. This raises a disquieting question. What exactly counts as an observer? Is it a human consciousness peering at the result, a measuring device registering data, or does collapse occur whenever systems interact, regardless of awareness? Here the debate splinters. The Copenhagen interpretation, once dominant, holds that measurement forces collapse, though it sidesteps the precise role of consciousness. Other interpretations avoid collapse entirely, suggesting every possible outcome occurs in branching universes. Yet the mystery remains. Why should measurement, why should knowledge matter to the fabric of reality? Albert Einstein, who helped birth quantum theory, recoiled from this implication. "Do you really believe the moon exists only when you look at it?" he asked. For Einstein, reality had to be objective, independent of observers. He preferred a universe of hidden variables, unseen causes determining outcomes beneath the haze of probabilities. But repeated experiments, from Bell's inequalities to delayed choice setups, have steadily eroded this hope. Reality does not behave like a classical machine. At its core, it seems tied to observation, as though awareness itself cannot be left out of the picture. Take Wheeler's delayed choice experiment, a haunting twist on the double slit. If we decide whether to observe the photon's path after it has already passed the slits, the result still changes accordingly. It is as if the present choice retroactively determines the past behavior of the photon. Reality bends to the act of observation, as though time itself defers to awareness. To think of the universe this way is unsettling, even heretical. It implies that the act of knowing is not passive, but formative. Of course, physicists disagree sharply on how to interpret this. Some argue that observation means any interaction with the environment, no mind required. Decoherence theory, for instance, explains collapse as the entanglement of a system with countless surrounding particles, leaving the appearance of definiteness without invoking consciousness. Yet even this avoids the deeper issue. The entire framework of physics is built on measurement, and measurement always returns to the act of awareness. Who reads the result? Who sees the data? Who decides what has happened? Strip away the abstractions, and consciousness lurks in the background, like an uninvited guest that cannot be expelled. Grasp the weight of this. Imagine reality as a story written in pencil. Without observation, the lines are sketches, blurred and uncertain, multiple possibilities layered over each other. Observation is the hand that inks the page, solidifying one version into permanence. The universe, then, is not a pre-written book but a manuscript co-authored by the act of observation itself. And if that is true, then consciousness may not be a latecomer in the cosmic play, but an actor central to its unfolding. This is why quantum mechanics unnerves even the most brilliant minds. It works flawlessly as a predictive tool, yet it whispers of something more profound, that reality is participatory. Niels Bohr put it bluntly: no phenomenon is a real phenomenon until it is an observed phenomenon. For Bohr, physics does not describe an independent world, but the relationship between the world and the observer. The observer is not outside the system but part of it. This is the quantum observer problem. It is not simply a puzzle of physics, it is a wound in our understanding of reality. If matter alone is primary, then why does observation matter? If consciousness is an illusion, why do the equations treat it as essential? Every interpretation, Copenhagen, many worlds, Bohmian mechanics, decoherence, tries to sidestep or explain away the observer. Yet none can fully erase the strangeness, that the universe seems to wait for awareness to finalize its state. For some, this is evidence that consciousness is fundamental. The von Neumann, Wigner interpretation boldly suggested that it is the human mind itself that collapses the wave function. Reality, in this view, is unfinished until it is observed by consciousness. The act of knowing is not peripheral but central. To many scientists, this borders on mysticism. Yet the paradox remains. If the wave function is only mathematical probability, why does it collapse at all? If the universe is independent, why does it behave as though awareness plays a role? Skeptics argue that consciousness is unnecessary. They point to the success of quantum theory without metaphysical add-ons. For them, the observer problem is a quirk of language, not a cosmic secret. Consciousness, they say, is just another physical process, and collapse is just interaction. Yet such arguments often leave the unease intact. If the entire machinery of physics depends on measurement, and measurement cannot be divorced from awareness, then consciousness cannot be so easily dismissed. The implications ripple outward. If observation shapes outcome, then what of the universe before observers existed? Were galaxies in superposition until the first creatures with eyes looked up? Was the Big Bang itself uncollapsed until consciousness emerged? These questions sound absurd, but they reveal the fault lines in the matter-first worldview. If physics demands the observer, then consciousness is stitched into the cosmos from the beginning. The machinery of matter cannot be cleanly separated from the mystery of mind. And so we arrive at the edge of certainty. The quantum observer problem is not a puzzle that can be neatly solved. It is a doorway into deeper questions. What is consciousness? What is reality? Are we passive witnesses or are we co-creators? To peer into the quantum world is to glimpse a universe where matter and mind intertwine, where the boundaries blur, where the impossible question returns with new urgency. The observer problem does not prove that consciousness shapes the universe, but it refuses to let us pretend that consciousness does not matter. And perhaps that is enough. Perhaps the very strangeness of quantum mechanics is a signal that our assumptions are incomplete, that reality is richer, stranger, and more participatory than the machinery of matter alone can explain. For most of physics, the safest move has always been to leave consciousness out. Equations describe particles, forces, and fields, not dreams, thoughts, and awareness. Yet the quantum observer problem refuses to vanish, and some thinkers have dared to face it directly. If observation seems to shape reality, then perhaps the mind belongs in the equations themselves. It is a dangerous idea, ridiculed by many, embraced by few, but impossible to ignore. What if consciousness is not an afterthought, but a principle woven into the very structure of physics? One of the earliest to consider this was John von Neumann, the mathematical genius who helped formalize quantum mechanics. In his 1932 book Mathematical Foundations of Quantum Mechanics, von Neumann argued that measurement cannot be explained by physical processes alone. Somewhere in the chain, from particle to detector to brain, something extra occurs. He suggested that collapse of the wave function ultimately happens only in the mind of the observer. Eugene Wigner, another giant of 20th century physics, extended this view, proposing that consciousness itself causes collapse. This is the so-called consciousness causes collapse interpretation. In it, the universe is not fully real until it is experienced by awareness. Matter does not dictate mind. Mind dictates matter. To many physicists, this was a step too far. It smacked of mysticism, a betrayal of the hard-earned objectivity of science. Yet the von Neumann-Wigner interpretation forced the community to confront an uncomfortable fact. The equations of quantum mechanics say nothing about collapse. They describe probabilities, not outcomes. Collapse, the jump from uncertainty to definiteness, is an add-on, a rule we impose. If collapse requires the mind, then consciousness is not a bystander. It is the key that locks possibility into actuality. Decades later, John Archibald Wheeler pushed the boundary further. Wheeler, a colleague of Einstein and mentor to Richard Feynman, coined the phrase "it from bit." Reality, he suggested, is not made of particles or waves, but of information. And information, by definition, requires observers. In his participatory anthropic principle, Wheeler argued that the universe exists because it is observed. The cosmos is not a pre-written book but an interactive story, brought into being by the act of questioning. In Wheeler's own words, we are participants in bringing about something of the universe in the distant past. Even the Big Bang, he speculated, may have required the participation of consciousness to be fully real. These ideas ignite awe and resistance in equal measure. On the one hand, they offer a way to make sense of the observer problem. On the other, they risk collapsing physics into solipsism, where reality is nothing more than mental projection. Critics argue that consciousness causes collapse is vague, untestable, and anthropocentric. Why should human awareness play a privileged role in the cosmos? Would the universe not exist without us? And yet, even the critics cannot fully erase the strange symmetry between quantum equations and the act of observation. Something happens when we measure, something inexplicable. Whether or not consciousness is the cause, it lingers as a suspect. In the 1990s, another bold attempt emerged, the Orchard theory, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Unlike von Neumann or Wigner, who placed consciousness outside physics, Penrose and Hameroff tried to bring it inside. They argued that consciousness arises from quantum processes within microtubules, tiny structures inside neurons. Penrose, inspired by Gödel's incompleteness theorem, believed that human understanding cannot be explained by algorithms alone. Something non-computable must be at play. He suspected that quantum gravity, the unknown theory uniting quantum mechanics with relativity, could provide the missing ingredient. In Orchard, consciousness is not epiphenomenal but fundamental, emerging from orchestrated quantum reductions that link the brain to the fabric of spacetime. The theory has been controversial, criticized as speculative and lacking evidence. Neuroscientists question whether fragile quantum states could survive in the warm, wet environment of the brain. Physicists doubt whether quantum gravity plays a role in cognition. Yet Orchard refuses to die. New research on quantum coherence in biological systems, from photosynthesis to avian navigation, suggests that life may indeed exploit quantum effects in ways once thought impossible. If birds can navigate by entangled particles, why could not brains harness similar principles? Even if Orchard is wrong in detail, its spirit, that consciousness belongs in physics, not outside it, has left a mark. What unites these daring theories is their refusal to exile the mind. They take seriously the possibility that consciousness is not a ghost in the machine, but part of the machinery itself. They risk ridicule to explore the unspoken. That awareness may be as real and as fundamental as spacetime, mass, or charge. And in doing so, they echo whispers from philosophy and mysticism alike, that the universe is not a dead stage but a living dialogue. Still, caution is warranted. To place mind in the equations is not to solve the mystery. It may only shift the problem. If consciousness collapses wave functions, what collapses consciousness? If the universe requires observation, who observed the first moment? If microtubules orchestrate awareness, why should quantum gravity feel like love, sorrow, or beauty? Each theory opens doors, but behind each door is another paradox. Consciousness resists capture, slipping through every net we cast. And yet these efforts matter. They remind us that physics is not finished, that reality may be stranger than we dare to formalize. Von Neumann, Wigner, Wheeler, Penrose, each in their own way dared to suggest that the universe cannot be understood without the mind. They offered not final answers but provocative invitations. Perhaps the machinery of matter is not enough. Perhaps we need to rethink the foundations. The scientific establishment often prefers safer interpretations. Many worlds, decoherence, hidden variables. These avoid the mind, preserving objectivity, but they leave an absence at the heart of the theory. Why this outcome and not another? Why anything experienced at all? To keep consciousness out may protect the purity of physics, but it also risks blindness to the very phenomenon that makes physics possible. Awareness may be inconvenient, but it is undeniable. This is why the mind keeps returning to the equations, no matter how hard we try to expel it. Physics is the story of measurement, and measurement is incomplete without awareness. To deny this is to build a palace of numbers without windows. To admit it is to open the shutters and face the unsettling light. Somewhere between arrogance and awe lies the truth. Consciousness belongs in the story, whether as participant, cause, or mystery. Physics can describe galaxies, quantum fields, and the birth of stars. Neuroscience can chart neurons, synapses, and chemical flows. But when it comes to explaining consciousness itself, the raw fact of subjective experience, both disciplines fall silent. This silence is not accidental, it is structural. No matter how detailed our descriptions of brain activity become, they cannot cross the chasm into what philosophers call qualia, the redness of red, the taste of chocolate, the sound of a violin, the feeling of being alive. This chasm is what David Chalmers famously named the hard problem of consciousness. The easy problems of consciousness are technical, though not trivial. They include explaining how brains discriminate stimuli, integrate information, or produce behavior. Neuroscientists can point to neural correlates of memory, attention, or emotion. They can map regions of the brain activated by sight, smell, or touch. These are the mechanics of cognition, the how of perception and thought. But the hard problem is different. It asks, why is there anything it is like to have these processes? Why does neural firing not occur in darkness? Why should matter, arranged in a particular way, feel like something from the inside? Thomas Nagel captured the essence of the problem in his essay, What Is It Like to Be a Bat? A bat perceives the world through echolocation, a mode of experience alien to us. We can study sonar, brain wiring, and behavior, but we can never know what it feels like to inhabit a bat's perspective. Consciousness, in this sense, is irreducibly first person. Science, by contrast, is third person. It observes, measures, and describes from the outside. The hard problem reveals the gap between these two modes of knowing. How can the subjective ever be reduced to the objective? Materialist accounts often argue that consciousness simply emerges from complexity. When enough neurons connect, when patterns of computation reach a threshold, subjective experience appears. But emergence is a label, not an explanation. It tells us when consciousness might occur, but not why. Why should computation, however advanced, feel like anything at all? A chess computer calculates, but it does not feel triumph or despair. A weather system processes vast amounts of information, but we do not assume it suffers when struck by a hurricane. Complexity alone does not guarantee experience. This is where the brain as generator model shows its limits. If consciousness is only a byproduct of matter, why does it resist being described in material terms? Why does awareness not reduce as neatly as digestion or respiration? Some thinkers propose the brain as receiver model instead. In this view, the brain is not producing consciousness but tuning into it, like a radio receiving signals. Consciousness would then be fundamental, with brains as instruments rather than factories. This is a radical shift, moving mind from accident to essence. The implications are staggering. If the brain is a receiver, then consciousness is not bound to the brain. It may exist beyond biology, perhaps even beyond spacetime itself. This possibility resonates with near-death experiences, reports of expanded awareness under psychedelics, and mystical traditions that treat consciousness as primary. Such ideas provoke skepticism, but they underline a crucial point. The hard problem forces us to consider that our framework may be incomplete. Perhaps physics and neuroscience in their current form are asking the wrong questions. Chalmers himself proposed that consciousness may be a fundamental property, like mass, charge, or spin. Just as physics does not explain why mass exists but takes it as given, perhaps we should take consciousness as a primitive of reality. This view, called panpsychism, suggests that consciousness pervades all matter at some level. Electrons, quarks, atoms, everything may possess a tiny spark of experience. In humans, these sparks integrate into rich awareness. In rocks, they remain dim, almost non-existent. Panpsychism does not solve the hard problem, but it reframes it. Instead of asking how matter produces mind, it asks how simple forms of mind combine into complex ones. Critics argue that panpsychism verges on animism, that it explains too much by attributing consciousness everywhere. Yet it avoids the central stumbling block of emergence, the leap from insentient matter to sentient beings. If consciousness is already built into the fabric of reality, the leap is softened. The question becomes not how consciousness appears, but how it organizes. In this way, panpsychism turns the hard problem from an abyss into a puzzle, still unsolved but no longer absurd. Still, the mystery deepens. Even if consciousness is fundamental, why does it have the qualities it does? Why should wavelengths of light correspond to the vividness of blue or red? Why should certain neural firings produce the pang of grief or the ecstasy of joy? The gap between physical process and subjective quality remains, a wound in the fabric of explanation. Philosopher Colin Maginn called this mysterianism, the idea that human minds may simply be incapable of solving the hard problem, just as a dog cannot solve calculus. Perhaps consciousness is forever beyond our reach. But to many, this resignation is unsatisfying. The very existence of the hard problem suggests that consciousness is trying to be taken seriously, that awareness is demanding its place in the story of reality. To dismiss it as illusion or irrelevance is to ignore the one thing we know with absolute certainty, the fact that we are aware. Everything else, atoms, galaxies, even the laws of physics, are abstractions inferred through experience. Consciousness is the ground upon which all knowledge rests. To call it secondary is to invert the obvious. The contrast sharpens when we consider thought experiments like the philosophical zombie. Imagine a being identical to you in every physical way, same neurons, same behavior, same words, but without subjective experience. From the outside, it appears conscious. From the inside, it is empty. If such a creature is conceivable, then consciousness cannot be reduced to physical processes alone. Something more is at play, something invisible to measurement yet undeniable to experience. This returns us to the paradox at the heart of our inquiry. Physics insists on universality, objectivity, independence. Consciousness insists on subjectivity, immediacy, dependence on perspective. How can the two be reconciled? Perhaps they cannot. Perhaps the universe has two faces, matter and mind, neither reducible to the other. Dual aspect theories like those of Spinoza suggest that reality is one substance with two aspects, physical and experiential. Science sees the physical, introspection sees the experiential. Both are true, both incomplete. The hard problem does not merely trouble philosophers. It seeps into every corner of our lives. If consciousness is only chemistry, then love is an illusion. If consciousness is fundamental, then love is as real as gravity. If mind emerges from matter, death is extinction. If matter emerges from mind, death may be transformation. The stakes are existential, not academic. How we answer or fail to answer. The hard problem shapes how we see ourselves and our place in the cosmos. And here the contrast becomes starkest of all. The matter-first worldview paints consciousness as a flicker in the void, soon to be extinguished. The mind-first worldview paints it as the canvas upon which the void appears. Which vision we accept changes everything. Are we accidents in an indifferent cosmos, or are we participants in a conscious universe? The hard problem forces us to confront this choice, not with proof but with perspective. Yet before leaping to speculation, we must acknowledge that we are not the first to wrestle with these questions. Long before neuroscience or quantum theory, ancient traditions grappled with the nature of awareness. From Vedanta to Buddhism to Platonic philosophy, the primacy of mind has been a recurring theme. Perhaps, in turning back to these echoes, we find not answers but resonances. For the hard problem may not be solved in the laboratory alone. It may require wisdom older than science itself. Long before the language of quantum mechanics or the diagrams of neuroscience, humanity wrestled with the enigma of consciousness. Ancient sages, mystics, and philosophers turned inward, not outward, seeking the source of awareness itself. What they found was not particles, but patterns of thought and being. Their visions differ in detail, yet they echo a striking theme, that mind precedes matter, and that the universe itself may be born from consciousness. If modern science stumbles at the threshold of the hard problem, ancient traditions claim to have walked through the door. In the philosophy of Advaita Vedanta, rooted in the Vedic texts of India, consciousness is Brahman, the ultimate reality. The world of forms, objects, and bodies is Maya, illusion or appearance. To awaken is to realize that the self, Atman, is not separate from Brahman but identical with it. In this view, matter is a projection, like images on a screen. Consciousness is the light that makes the screen visible at all. The mind is not trapped in the universe is trapped in the mind. Buddhism approaches from another angle, yet arrives at a similar insight. The doctrine of sunyata, or emptiness, denies that phenomena have inherent existence. Things appear, but their reality is interdependent, arising only in relation to perception and awareness. Meditation reveals the flickering, dreamlike quality of reality, dissolving the illusion of solidity. In this tradition, consciousness is not a self-contained soul, but a field of awareness in which the illusion of self and world co-arise. To awaken is to see that matter and mind are not separate, but inseparable, two sides of the same emptiness. The Greeks, too, pondered the primacy of mind. For Plato, the realm of ideal forms existed beyond the material world. A perfect circle, a just act, or pure beauty cannot be reduced to physical matter. They exist in a higher, immaterial reality. The visible world is a shadow of this deeper truth, a dream compared to the clarity of forms. The soul, in contact with this realm, knows more than mere matter could ever provide. In his allegory of the cave, prisoners mistake shadows for reality until they turn toward the light. The parallel to modern debates is uncanny. Are we still staring at shadows, mistaking matter for the whole of reality, while consciousness is the light behind it? Indigenous traditions around the globe also resonate with this theme. Many Native American cosmologies describe a world in which spirit suffuses matter. Rocks, rivers, and winds are alive, not metaphorically but literally. Consciousness is not limited to humans but shared by all beings. In some Aboriginal Australian traditions, the dream time is the primordial dimension from which the world emerges and continues to be sustained. Here, reality is not fixed but ongoing, woven by stories and awareness. To live is to participate in this dream, not to stand outside it. Mystics across centuries echo similar metaphors. Rumi, the Sufi poet, wrote that the universe is not outside you but within. Meister Eckhart, the Christian mystic, spoke of a divine spark at the center of the soul that unites with God. Taoist sages describe the Tao as the ineffable source from which yin and yang flow, with consciousness as the harmony that perceives both. Despite differences of culture and doctrine, the threads converge. Matter is not ultimate, awareness is. The cosmos is not a machine, but a mystery unfolding in mind. Skeptics might dismiss these traditions as pre-scientific myths born of ignorance, and indeed they lack equations or experiments, yet their endurance suggests they touch something perennial. They speak to the immediacy of awareness, to the undeniable fact that experience is prior to explanation. Where science seeks to measure, these traditions sought to witness. Where physics builds models, mysticism builds insight. Perhaps they are not competitors, but complements, two languages describing the same ineffable reality. Modern thinkers often note the resonance between quantum paradoxes and ancient insights. The wave-particle duality recalls the Buddhist doctrine of non-duality. The participatory anthropic principle mirrors Vedantic claims that consciousness sustains the world. The holographic principle in physics, suggesting the universe may be like a projection from a boundary, sounds eerily similar to Maya. These parallels may be coincidence, or they may reveal that when reason and intuition both face the same mystery, they stumble upon similar metaphors. The power of these echoes lies not in their literal accuracy but in their contrast with modern reductionism. Where materialism paints consciousness as a flicker in matter, ancient traditions reverse the hierarchy. Awareness is the canvas, matter the paint. The universe is not indifferent machinery but meaningful appearance. This inversion reframes not just metaphysics but ethics. If matter is all, life is disposable. If consciousness is fundamental, every being is sacred. Yet the ancient echoes also remind us of humility. The mystics did not claim to solve the mystery, only to dwell within it. Their insights were experiential, not empirical. To modern science, this is weakness. To philosophy, it may be wisdom. For perhaps consciousness is not a problem to be solved, but a reality to be recognized. The hard problem, reframed, is not why consciousness exists, but why we assume it does not. Still, even the most poetic parallels cannot substitute for evidence. If consciousness truly shapes reality, it must leave traces, effects, anomalies that can be tested. And indeed, at the edges of science, experiments have been attempted. controversial, contested, but provocative. From random number generators to meditative influence on physical systems, researchers have tried to measure what mystics intuited. Whether these experiments succeed or fail, they force us to confront the same possibility: that awareness is not passive but active, not derivative but causal. For centuries, science has sought to keep the boundary clear. Physics explains matter, psychology explains mind. Yet if consciousness truly shapes the universe, this border begins to blur. What if awareness is not a passive witness but an active force? If so, then its fingerprints should be detectable. This question has led some researchers to walk the thin line between science and speculation, designing experiments that test whether the mind can reach beyond the skull. The results are controversial, often dismissed, yet impossible to ignore. At the edges of science, whispers emerge that consciousness may leave measurable traces. One of the most famous efforts came from the Princeton Engineering Anomalies Research Lab, PAIR, founded in 1979 by Robert John, a professor of aerospace engineering. For nearly 3 decades, the lab investigated whether human intention could influence physical systems. Using random number generators, devices designed to produce unpredictable sequences of zeros and ones, the researchers asked participants to mentally, will the machines toward more zeros or more ones? The results, aggregated over millions of trials, suggested tiny but consistent deviations from chance. Skeptics argued these were statistical artifacts. Believers saw them as evidence that consciousness could subtly nudge matter. The experiments at PAIR extended beyond numbers. Volunteers attempted to influence the movement of falling balls in pinball-like devices, or to shift patterns in laser light. Again, the effects were small, but the data seemed to show that intention mattered. John and his collaborator Brenda Dunn concluded that consciousness and physical systems might be entangled in ways our models cannot explain. To mainstream physics, this was heresy. Yet the persistence of the anomalies raised an unsettling possibility. Perhaps mind and matter are not separate domains at all. Other laboratories have pursued similar lines of inquiry. The Global Consciousness Project, launched in 1998, extended the PAIR experiments worldwide. Random number generators were placed in dozens of locations, continuously recording data. The hypothesis was bold: if collective human consciousness has an effect, then during moments of global coherence, mass celebrations, tragedies, or meditations, the random streams should shift measurably. During events like the 9/11 attacks, the funeral of Princess Diana, or New Year's Eve celebrations, some deviations were reported. The interpretation is debated. Do these anomalies reflect human emotion rippling into machines, or are they artifacts of selective analysis? Either way, the project embodies the daring attempt to quantify the unquantifiable. Beyond random machines, researchers have explored the intersection of consciousness with quantum phenomena. Inspired by the observer problem, some experiments test whether human attention can influence quantum outcomes. For instance, studies using the double-slit experiment have examined whether focused intention alters interference patterns. In some cases, faint correlations were reported. Critics argue that such results vanish under stricter controls. Yet the very attempt reflects a deeper question. If observation collapses the wave function, might consciousness play more than a symbolic role? Another frontier lies in psychophysiology. Studies of meditators, shamans, and healers suggest that altered states of consciousness can produce measurable physical effects, both internally and externally. Brain waves synchronize, heart rhythms shift, even immune responses appear to strengthen. Some traditions claim that these states allow influence beyond the body, affecting plants, water crystals, or even distant minds. The famous, if controversial, experiments of Masaru Emoto purported to show that human intention could alter the structure of frozen water, producing more symmetrical crystals when exposed to loving words or prayers. Mainstream science critiques the lack of rigor. Yet the popularity of such claims reveals a hunger for evidence that consciousness is more than an internal flicker. Remote viewing, studied by government programs during the Cold War, further complicates the picture. The U.S. military and CIA funded research into whether individuals could perceive distant locations or events without sensory contact. Some results, such as those from the Stanford Research Institute, suggested above-chance accuracy. While the programs were eventually shut down, the data remains contested. Was it flawed methodology, or did it hint at non-local aspects of consciousness? The very fact that serious institutions invested resources in such research reflects how persistent the question has been. Does mind extend beyond matter? To be fair, the criticisms are strong. Skeptics note that tiny statistical deviations can arise from flawed controls, unconscious biases, or selective reporting. Replications often fail. Extraordinary claims require extraordinary evidence, and much of the data at the edges of science falls short. The mainstream insists that until results are robust, repeatable, and theoretically grounded, they belong to the realm of pseudoscience. And yet, history reminds us that many once dismissed ideas, from meteorites to continental drift, later became accepted. The line between anomaly and breakthrough is thin. What makes these experiments so provocative is not their certainty, but their ambiguity. They suggest that the universe may be slightly responsive, that consciousness might leave fingerprints too faint to ignore. Even if the effects are small, their very existence would challenge the assumption that mind is sealed inside matter. Imagine a coin that, over millions of flips, is nudged ever so slightly by thought. Such a possibility would revolutionize our understanding of causality. Even if the evidence remains disputed, these experiments serve a vital role. They keep the question alive. They remind us that consciousness is not just a philosophical puzzle, but a phenomenon that may interact with the world in ways we do not yet comprehend. They push the boundaries of what science is willing to test, daring to quantify the ineffable. And they highlight the contrast between certainty and curiosity, between those who dismiss anomalies as noise and those who hear in them the whispers of a deeper truth. Consider how this mirrors the history of science itself. Every major paradigm shift began with anomalies that did not fit. The orbit of Mercury, unexplained by Newton, hinted at Einstein's relativity. The ultraviolet catastrophe, an error in classical physics, opened the door to quantum mechanics. If consciousness truly shapes reality, the anomalies we dismiss today may be the seeds of tomorrow's revolutions. At the same time, we must be cautious. Human beings are prone to seeing patterns in noise, to projecting meaning where none exists. The desire to prove consciousness powerful can bias our interpretations. To move forward, experiments must become more rigorous, more transparent, more reproducible. The edge must sharpen into clarity. Only then can we distinguish fantasy from frontier. Yet even in skepticism, one fact remains: consciousness is undeniable. We know it not because of data, but because of direct experience. We cannot measure love, but we feel it. We cannot quantify awe, but we are moved by it. Experiments on the edge may fail, but they arise from the most certain truth, that awareness exists, and its relationship to matter is not yet fully known. The question lingers: if consciousness has even the faintest influence on matter, what does that say about the universe? Could it mean that reality is not indifferent but participatory? Could it mean that awareness is not a passenger but a co-creator? The experiments at the edge do not settle the debate, but they keep the door open. And sometimes, keeping the door open is the most radical act of all. What if the universe is not made of matter at all? What if beneath atoms, quarks, and forces lies something more abstract, something that feels closer to mathematics than to mechanics? Increasingly, physicists and philosophers suggest that the true foundation of reality may be information. Matter and energy, space and time, may be emergent patterns in a deeper informational substrate. And if that is true, then consciousness is not a bystander but the interpreter, the decoder, perhaps even the programmer of existence itself. This perspective finds one of its boldest champions in John Archibald Wheeler, the legendary physicist who coined the phrase "it from bit." For Wheeler, every physical thing, every it, ultimately arises from binary choices, from bits of information. The universe is not built of solid stuff but of yes or no questions, measurements, distinctions made by observers. Reality, in this view, is participatory. It comes into being through acts of information exchange. A photon is not fully real until it is measured, its possibilities collapsed into one outcome. Each observation is like a bit flipped in the cosmic code. Without these informational choices, Wheeler suggested, there would be no reality at all. This idea resonates deeply with the quantum observer problem. When a wave function collapses, what happens if not the registration of information? A haze of probabilities becomes a fact, uncertainty becomes certainty, the unknown becomes known. The universe, then, may not be a machine grinding away but a vast information processor, with consciousness as its interpreter. Observation is not an accident. It is the very act that turns potential into actual data into reality. Modern physics has expanded on Wheeler's intuition. In digital physics, reality itself is modeled as computation. The universe is like a giant quantum computer, with every interaction a calculation, every particle a data point. Seth Lloyd, a pioneer of this view, has suggested that the universe has been processing information since the Big Bang, running on the ultimate quantum hardware, spacetime itself. From this angle, galaxies, stars, and even life are outputs of a cosmic computation. The cosmos is not matter in motion, but information in evolution. The holographic principle, developed in the context of black hole physics, pushes the vision further. According to this principle, the information content of a region of space is encoded not in its volume but on its boundary. Just as a hologram stores a 3D image on a 2D surface, the entire universe may be encoded on a distant boundary of spacetime. Reality, then, is a projection, a display of information. What we experience as depth, solidity, and motion may be shadows of a cosmic code written on the horizon of the universe. If so, matter is appearance, information is essence. In this framework, consciousness takes on a pivotal role. Information is meaningless without interpretation. A sequence of ones and zeros is inert until read by a mind. If the universe is code, then consciousness is the reader, the decoder that translates binary distinctions into lived experience. More radically, consciousness may not merely read the code but write it. By observing, by distinguishing, by knowing, awareness participates in the ongoing computation of reality. Each act of perception is a line of code executed, a choice made real. This view bridges science and philosophy in provocative ways. In Plato's time, forms were eternal templates shaping the world. In the information paradigm, bits are the modern forms, abstract structures shaping matter. Where mystics spoke of the world as illusion, physicists now speak of the universe as simulation. Where spiritual traditions describe the world as dreamlike, scientists describe it as holographic. Information theory provides a language where ancient metaphor and modern physics converge. Of course, critics caution against overextending the analogy. Information is not an ethereal entity. It is always about something, always grounded in physical systems. A bit requires a medium, an electron's spin, a photon's polarization, a transistor's state. To claim that information alone is real risks circularity. Yet even here, the boundary blurs. If matter itself is described entirely by informational states, then matter and information are indistinguishable. What we call particles may simply be stable configurations of bits. What we call laws of physics may be algorithms running on cosmic hardware. This leads naturally to the simulation hypothesis, which argues that our universe might literally be a programmed reality. If information is fundamental, then there is no reason, in principle, why conscious beings could not simulate entire universes. If advanced civilizations exist, they could run countless simulations. each indistinguishable from what we call base reality. In this dizzying vision, our cosmos is not a material stage but a virtual theater. Consciousness, then, is both player and played, living inside a program it may itself have authored at another level. Even without invoking simulations, the informational paradigm changes everything. It reframes questions of meaning, causality, and existence. If reality is information, then the universe is not indifferent but responsive. Information is relational. It requires interaction, exchange, recognition. This implies that awareness is not an accident but a necessary partner in the unfolding of the cosmos. To exist is to be information, and to be information is to be knowable. The universe, then, is not a blind mechanism, but a story constantly being read and written. This shift also recasts the role of science itself. For centuries, science has sought to strip away subjectivity, to describe reality in purely objective terms. But in an informational universe, subjectivity is not noise, it is signal. Consciousness is not excluded, it is the decoder ring that makes sense of the data. To ignore it is to miss half the equation. In this way, the informational view restores consciousness to the center of the cosmic drama, not as a ghost in the machine, but as the reader of the code. The awe of this perspective lies in its paradox. On one hand, reality is stripped down to abstract bits, the cold logic of zeros and ones. On the other, those bits blossom into the richness of lived experience. Sunsets, symphonies, love, sorrow. From binary distinctions arises the infinite texture of existence. Information is at once austere and exuberant, abstract and intimate. To see the universe as information is to glimpse both its mathematical skeleton and its poetic soul. And yet this view leaves open a haunting question. If reality is information, who or what is the ultimate observer? Who ensures that the code is read, the bits executed, the program running? Are we the final interpreters, or are we themselves subroutines in a larger consciousness? In an informational universe, the line between player and program, observer and observed, blurs. Consciousness may not simply decode the cosmos. It may be the cosmos, dreaming itself in code. If the universe is information, then one question rises above the rest. Who, or what, is running the program? The idea that reality itself might be a simulation has leapt from philosophy departments into popular culture, fueled by films like The Matrix and the musings of scientists and entrepreneurs alike. Yet beneath the science fiction lies a serious proposition, that everything we see, touch, and feel could be the output of a vast computational system, a theater of code designed, or perhaps self-generated, for consciousness to inhabit. The simulation hypothesis, articulated most famously by philosopher Nick Bostrom, rests on a trilemma. If civilizations can survive long enough to develop advanced computing, and if such civilizations choose to run simulations of their ancestors, then the number of simulated worlds would vastly outnumber real ones. If that is true, then the probability that we are living in base reality is vanishingly small. Statistically, we are more likely to be characters in a program than physical beings in an ultimate universe. What we call atoms may be pixels. What we call laws of physics may be code. The implications are staggering. If reality is simulation, then consciousness may not emerge from matter but from computation itself. Our thoughts, feelings, and perceptions would be outputs of algorithms, no less real for being digital. Yet the haunting question remains. If we are in a simulation, does that make our experiences less authentic? Or does it reveal that authenticity is defined not by substrate but by awareness? After all, if pain hurts, joy uplifts, and beauty moves us, what difference does it make whether we are biological or digital? Consciousness, in this view, is substrate independent. It arises wherever information flows in certain patterns. Still, the simulation idea collides with deeper paradoxes. If we are simulated, who are the simulators? Are they beings in a higher-level universe, running programs for research, entertainment, or something we cannot imagine? Or is the entire hierarchy infinite, with simulations nested inside simulations, reality stacked like Russian dolls? If so, where is the ultimate base reality? And would we ever know if we reached it? The hypothesis solves some mysteries but opens a labyrinth of others. Alongside the simulation idea runs another dizzying possibility, the multiverse. Instead of one universe or one program, there may be countless. In quantum mechanics, the many worlds interpretation suggests that every possible outcome of every event actually occurs, branching into parallel realities. In one world, Schrödinger's cat lives, in another, it dies. In one, you watch this video, in another, you never find it. Each decision, each quantum event, spawns new universes, endlessly multiplying. Reality is not a single line but a vast, branching tree. Cosmology offers its own multiverse visions. Inflationary theory suggests that our universe may be one bubble among countless others, each with its own laws of physics. String theory posits a landscape of possible universes, each with different configurations of fundamental constants. In this view, the cosmos is not tuned for life by chance, but because we inhabit one of the rare universes where life is possible. Just as fish only swim in water, conscious beings only awaken in universes that allow consciousness. The multiverse and the simulation hypothesis may seem distinct, but they converge in curious ways. If simulations can generate universes, then each simulation is effectively its own cosmos. And if every quantum event spawns branches, then the act of simulation may itself multiply realities. The line between simulated and real, between parallel and base, begins to blur. Reality may not be singular at all but plural, layered, recursive. Where does consciousness fit in this dizzying architecture? Some argue that consciousness is simply a passenger, waking up wherever conditions allow, whether in base reality, a simulation, or a parallel universe. Others suggest that consciousness is the thread stitching these realities together, the observer moving through branches, the decoder navigating layers of code. In the many worlds interpretation, for instance, every outcome exists, but our conscious experience flows through one branch at a time. The observer then becomes the navigator, selecting a path through the infinite maze. This raises a provocative possibility. Consciousness may not only interpret reality but generate it. In simulation terms, awareness may be both player and programmer, both avatar and author. In multiverse terms, consciousness may collapse possibilities into experience paths, shaping which universes are realized in awareness. The observer effect, writ large, becomes cosmic, mind as the engine that selects, writes, or sustains realities. Yet the contrast sharpens when we confront skepticism. Critics of the simulation hypothesis argue that it merely shifts the mystery upward. If we are simulated, who simulated our simulators? If consciousness is emergent in code, why should code produce qualia at all? The hard problem returns, now dressed in digital clothing. Similarly, critics of the multiverse point out that if parallel universes are unobservable, they may be metaphysical speculation rather than science. A theory that explains everything explains nothing, they argue. Without testable predictions, the multiverse risks being philosophy in disguise. Still, even skeptics cannot erase the haunting logic. Both simulation and multiverse hypotheses emerge not from mysticism, but from the mathematics of physics and computation. They are natural extrapolations of our best theories, however unsettling their implications. Whether true or not, they reshape the way we think about consciousness. For if reality is one among many, or one among infinite simulations, then awareness itself may be the only certainty. Consciousness is the anchor in the storm of possibilities, the witness that persists regardless of substrate. The existential implications are profound. If we live in a simulation, ethics and meaning are not erased, they are intensified. Our choices may be the very data the simulation seeks to generate. If we inhabit a multiverse, every possibility may occur, but the one we experience still matters. Consciousness, then, is the compass, the point where infinite branches narrow into one lived life. Whether digital or cosmic, simulated or parallel, the mind is the center of meaning. And perhaps this is the lesson hidden in both ideas. that the universe is not indifferent but participatory. If simulation, then we are participants in a program of unknown purpose. If multiverse, then we are participants in a branching web of possibilities. In both cases, consciousness is not trivial but essential. Without awareness, there is no observation, no code executed, no universe experienced. Mind, then, may be the through line that makes all realities real. The awe of this vision lies in its paradox. It expands the cosmos to infinity, whether through simulations nested without end or universes branching without limit. Yet it also contracts everything to a single point, the conscious experience here and now. Amid infinite realities, the fact that you are aware, listening, thinking, cannot be simulated away. It is the one truth that no hypothesis can erase. What if consciousness is not rare, fragile, or confined to human brains at all? What if it is everywhere, woven into the fabric of existence like gravity or electromagnetism? This is the radical proposition of panpsychism, that consciousness is a fundamental property of reality, present even in the tiniest particles. To many, this sounds absurd, a regression to animism. Yet to others, it is the most elegant solution to the hard problem of consciousness. If mind seems impossible to generate from matter, perhaps it was never generated at all. Perhaps it was always there. The allure of panpsychism lies in its simplicity. Instead of explaining how inert matter suddenly awakens into experience, panpsychism assumes that all matter has some degree of experience, however minimal. An electron may not write poetry, but it may have a glimmer of proto-experience, a faint what it is like to exist. Complex systems, like brains, integrate these sparks into richer awareness. In this view, consciousness scales with complexity, but it is never absent. The universe is not divided into dead matter and living mind, but is a continuum of experience. Philosopher Galen Strawson has argued forcefully for this perspective. He points out that consciousness undeniably exists, we know it directly, and that matter undeniably exists, we observe it everywhere. If science struggles to bridge the two, perhaps the divide is false. Matter and mind may be two aspects of the same reality. Panpsychism, he claims, is not mystical but inevitable, the only way to make sense of how experience fits into the natural world. The alternative, that consciousness arises from nothing, is more fantastical still. This idea resonates with strands of philosophy and mysticism across cultures. In Advaita Vedanta, Brahman is pure consciousness pervading everything. In Taoism, the Tao animates all forms. Indigenous traditions often regard the world as alive with spirit, from rocks to rivers. Panpsychism, far from being new, may be a modern rediscovery of ancient intuitions. The difference is that today it is being reframed in the language of philosophy of mind and physics, not poetry or myth. But how could such a view be tested or formalized? One promising approach comes from integrated information theory, IIT, proposed by neuroscientist Giulio Tononi. IIT suggests that consciousness corresponds to the degree of integrated information in a system, quantified by a value called phi. A system with high integration, like a brain, has rich consciousness. A system with little integration, like a rock, has minimal or none. In this framework, consciousness is not binary but graded, distributed across all structures that integrate information. While debated, IIT provides a possible bridge between subjective experience and objective measurement, grounding panpsychism in testable terms. If consciousness pervades everything, what does that mean for the cosmos as a whole? Here we arrive at the notion of cosmic consciousness. Instead of countless fragments of awareness, the universe itself may be a single, vast field of mind, of which individual beings are localized expressions. Just as waves rise and fall on the surface of an ocean, our experiences may be ripples in a cosmic sea of awareness. This idea, once mystical, now finds echoes in physics. Some interpretations of quantum entanglement, for instance, suggest that the universe is non-local, interconnected at a deep level. Consciousness, in this context, may be the binding field, the hidden fabric knitting all things together. The vision of cosmic consciousness transforms our place in the universe. If mind is everywhere, then our awareness is not isolated but continuous with the whole. The boundary between self and world, between subject and object, dissolves. To look at the stars is not to gaze at something alien, but to commune with another form of consciousness. To act in the world is not to manipulate inert matter, but to participate in a shared field of being. Ethics in this view expands naturally. Harm to others is harm to self. Care for the world is care for the cosmic mind. Critics push back, arguing that panpsychism is vague, untestable, or anthropomorphic. How could an electron be conscious? How could a rock feel anything? But panpsychists respond that these objections misunderstand the claim. Consciousness at the microlevel need not resemble human experience. It may be unimaginably simple, a raw proto-experience with no thoughts, images, or emotions. The richness we know emerges only when these fragments combine in complex ways. Just as life is built from molecules that are not alive, consciousness may be built from proto-experiences that, alone, are primitive but, together, blossom into awareness. This perspective also avoids one of materialism's deepest pitfalls, the sudden leap from unconscious to conscious. If matter is wholly insentient, then consciousness emerging from it is a miracle. If matter always carried experience, however faint, then the emergence of mind is a natural unfolding. Consciousness, like complexity, scales upward without ever appearing from nothing. The universe, then, is not a machine that accidentally grew a soul, but a soul that has always been expressing itself through machines. The idea of cosmic consciousness also resonates with modern reports of altered states. Mystical experiences, near-death experiences, and psychedelic journeys often describe dissolution of the ego and union with a larger field of awareness. People report feeling that the universe itself is alive, that they are one with all things. To skeptics, these are hallucinations. To panpsychists, they are glimpses of truth, moments when the localized ripples of mind merge back into the ocean. Science cannot yet adjudicate these claims, but their consistency across cultures and centuries is striking. If the cosmos is conscious, what is its purpose? Here we tread into speculation, but a recurring theme is that the universe seeks to know itself. Through stars, galaxies, and eventually life, the cosmos evolves complexity sufficient to reflect on its own existence. Human beings in this vision are not accidents but instruments, eyes through which the universe beholds itself, voices through which it speaks. Carl Sagan's poetic line, "We are a way for the cosmos to know itself," acquires literal meaning. Consciousness is not incidental, it is the point. Still, questions remain. If the universe is conscious, why is it so often indifferent, even cruel? Why does suffering exist? Why does awareness come laced with pain? Mystics have offered many answers, that suffering is illusion, that it is the price of free will, that it is the contrast necessary for growth. Panpsychism does not resolve this problem but reframes it. If consciousness is fundamental, then suffering is not incidental but intrinsic, a feature of awareness itself. The universe dreams, and dreams can be terrifying as well as sublime. The beauty of panpsychism and cosmic consciousness lies not in final answers, but in the way they invert our perspective. Instead of mind as a latecomer, they place it at the origin. Instead of a dead cosmos, they envision a living one. Instead of human beings as anomalies, they cast us as expressions of a universal principle. Whether true or not, these ideas expand the horizon of possibility, urging us to see the world not as inert matter but as a field of meaning. If consciousness permeates the universe, the question naturally turns inward. What is the role of human beings in this grand design? Are we merely fleeting sparks of awareness produced by a vast cosmic mind? Or are we creators in our own right, shaping the very fabric of reality through thought, intention, and perception? The tension between these two roles, created and creator, defines the drama of human existence. The traditional scientific narrative casts us firmly as created. Evolution sculpts us from the dust of stars, shaping bodies and brains through natural selection. Our thoughts and emotions, under this view, are adaptive tools for survival. We are products of forces indifferent to us, temporary whirlpools in the stream of matter and energy. In this perspective, to ask about purpose is to mistake the indifferent machinery of the universe for a storybook. We are characters without authors, actors without a script. And yet the evidence of experience resists such stark reduction. Every human being feels like more than a biochemical machine. We love, we suffer, we dream, and in doing so we give shape to realities that extend beyond the physical. The placebo effect demonstrates that belief alone can trigger healing responses in the body. Synchronicities, a word popularized by Carl Jung, suggests that inner states and outer events can align in meaningful patterns. If consciousness were merely a byproduct, how could it wield such influence? These phenomena may not rewrite physics, but they whisper that mind is not passive. Our creative capacity is most obvious in culture. Languages, stories, laws, and technologies are not carved into stone by nature. They are born from thought. Human imagination transforms landscapes, builds civilizations, launches satellites. A cathedral is no less real than a mountain, though one emerges from geology and the other from consciousness. In this sense, we are creators, weaving mind into matter, embedding meaning into the physical world. If the cosmos is conscious, then humanity may be one of its most articulate voices, speaking itself into new forms. The duality of created and creator becomes starker when we consider the ethical stakes. If we are only created, our actions are insignificant. The universe would carry on unchanged without us. But if we are creators, then our choices ripple outward, shaping not only our lives but the field of consciousness itself. The recognition of responsibility emerges here. To act with cruelty or carelessness is not just to move atoms, it is to sculpt the living fabric of reality. To love, to create beauty, to seek truth may be acts of cosmic participation, not mere private indulgences. Some traditions even claim that human beings are co-creators with the divine or the universe itself. The Kabbalistic idea of tikkun olam speaks of repairing the world, not as a metaphor but as a genuine cosmic task. In Hindu thought, humans participate in the play of Leela, the divine game of creation and destruction. In modern spiritual movements, people speak of manifestation, the idea that focused intention can alter external circumstances. While often dismissed as wishful thinking, such practices echo the deeper possibility that human consciousness is not isolated but entangled with reality at large. Skeptics caution that this veers into hubris. To believe we create reality risks anthropocentrism, inflating our importance in a universe that dwarfs us. And indeed, the cosmos stretches billions of light years, indifferent to our desires. Stars explode regardless of our dreams. Galaxies collide without our permission. In this sense, we are undeniably created, bound by laws we did not write, subject to mortality we cannot escape. To forget this is to fall into illusion. But to deny our creative role entirely is to overlook the undeniable. The world we live in, the world of meaning, relationship, and identity, is co-created by human consciousness. No law of physics predicts the poetry of Rumi, the symphonies of Beethoven, or the political revolutions that reshape societies. These emerge from the interplay of matter and mind, from the peculiar power of human beings to translate imagination into reality. We are both insignificant and significant, dust and dreamers, created and creators. The paradox intensifies when we return to quantum mechanics. If observation collapses probabilities, then every human act of awareness shapes the universe at least microscopically. If consciousness is participatory, then our role is not trivial. We are threads in the cosmic loom, and our choices alter the pattern. Even if the effects are subtle, their accumulation may be profound. The question is not whether we shape reality but how responsibly we do so. Consider the metaphor of a symphony. Each instrument is small, its sound fleeting, yet together they produce music that fills a hall. Humanity may be such instruments in the symphony of cosmic consciousness. Alone, we are fragile. Together, we generate harmonies or dissonances that shape the unfolding song. The cosmos does not hand us a score, it hands us an instrument. How we play is up to us. This view transforms the meaning of human life. If we are only created, then our lives are accidents, fleeting sparks soon extinguished. If we are creators, then every thought, every action is part of the ongoing creation of the universe. We may never control the stars, but we can shape the human world, and perhaps more subtly, the field of awareness itself. Our role, then, is double: to accept our createdness and embrace our creativity. To recognize that we are both products of the cosmos and participants in its continual becoming. This double role also reframes mortality. If consciousness is derivative of matter, then death is extinction. If consciousness is fundamental, then death may be transformation, the merging of the localized wave back into the cosmic ocean. Either way, the life we live matters, not because it lasts forever, but because it contributes to the unfolding of reality. The imprint of consciousness may ripple beyond what we can measure, but it is never nothing. The awe of this perspective lies in its balance. We are not gods, yet we are not accidents. We are finite beings with infinite significance. We did not choose the laws of physics, but within them we create meanings, stories, and worlds. To be human is to be both created and creator, to live at the intersection of dependence and freedom, limitation and possibility. This paradox is not a flaw but a gift, anchoring us in humility while inviting us into responsibility. We began with a paradox. Does the universe give rise to consciousness, or does consciousness give rise to the universe? Across our exploration, we have seen how physics, philosophy, and mysticism circle this question without settling it. Quantum mechanics whispers that observation matters. Philosophy insists that subjective experience cannot be erased. Ancient traditions proclaim that awareness is the ground of being. And modern speculation imagines information, simulations, and multiverses where consciousness is central. No single view resolves the paradox, yet perhaps the point is not to solve it, but to awaken to it. The power of this journey lies in its reversal. For most of history, we have told ourselves that we are small, insignificant passengers in a blind cosmos. But the evidence, both scientific and experiential, suggests a different story. We are not merely observers but participants. The universe is not a completed object but a living process, shaped in part by our awareness. To awaken to this is to close the loop, to realize that the act of observing is itself an act of creation. This awakening transforms how we see reality. If the universe is machine, then life is accident. If the universe is mind, then life is expression. Each perspective carries its weight, but only one recognizes the undeniable fact of awareness. Consciousness is not an add-on to reality. It is the medium in which reality appears. Every star we see, every sound we hear, every memory we hold exists only because it is experienced. To awaken is to see that the universe is not outside us, but within us, unfolding through the very act of being aware. The implications are not abstract. They touch every choice we make. If consciousness shapes reality, then our thoughts, words, and actions matter in ways deeper than we imagine. Love and cruelty, hope and despair, do not simply color our private lives. They ripple outward into the shared field of mind. Responsibility becomes cosmic. Awakening the observer means recognizing that we are accountable not just for what we do, but for how we perceive. Each act of awareness is a brushstroke on the canvas of the universe. And yet, awakening also brings humility. To participate in creation is not to control it. We did not author the laws of physics, nor can we command the stars, but we can shape our corner of reality, co-creating meaning with the cosmos. To awaken the observer is not to declare ourselves gods, but to recognize ourselves as conscious threads in the infinite tapestry. The gift is not omnipotence, but participation. This is the closing of the loop. The universe awakens to itself through us, and we awaken to ourselves through the universe. The mirror reflects endlessly. Matter gives rise to mind gives rise to matter. Perhaps the question of which comes first is less important than the realization that the two are inseparable. The loop is not a flaw but a feature, an eternal dialogue where subject and object co-create. To awaken is to stop seeking outside and recognize the circle we are already in. The final challenge is to live as if this is true, to carry the awareness that every perception is participation, that every choice reverberates in the cosmos, to see consciousness not as trivial but as sacred. Whether or not science ever proves that mind shapes matter, awakening the observer changes how we move through life. We become less passive, more responsible, more attuned to the mystery shimmering in every moment. And so we end where we began, with awe that the universe exists at all, awe that we are here to witness it, awe that, in some profound and perhaps inescapable sense, the act of witnessing may itself sustain it. The impossible question remains unanswered, but it has become a doorway rather than a wall. To step through is to awaken, not to certainty, but to wonder.